We had some practice with worksheet 2 uh, on the back, how to take a position time graph and translate it to a velocity time graph. Let's take a closer look at that with page 12.5. Let's look carefully what we're starting with. We have a position versus time graph, right? And it is labeled 0 position to 6 meters and 0 to 5 seconds. The key to translating a position time graph into its velocity versus time representation is the slope, because the slope of a position versus time graph is the velocity. So let's work with this one here. We'll take the slope, and you pick 2 points that are convenient and make a slope triangle. These 2 points are easy to read. Make a triangle, and then the rise here I see 1, 2, 3, 4, 5, 6 meter rise in a 2-second run, right? These are seconds down here. So the slope is rise of 6 meters over 2 seconds. Now, that velocity, I need to get that per every 1 second. So 6 meters every 2 seconds is the same as 3 meters every 1 second. So this is the slope, this position versus time graph for the first 2 seconds of motion. So that's the velocity of the object. So now we have to put the numbers in here. This would be 0 velocity along the time axis. This would be 1 meter per second, 2, and 3. This would be -1, -2, and -3 meters per second. And the minus would mean a decreasing position. This object is increasing position, so it's a +3 meters per second, and that lasts for 2 seconds. Then there's a change right here in the motion, and this object looks like it doesn't change its position. It stands still for the next 3 seconds, from 2 to 5 seconds. So from 1, 2 seconds here to 3, 4, 5 seconds, the velocity versus time graph is just along the 0 velocity. I can connect these two levels of velocity with a vertical line. So this is the velocity time graph that represents the motion that is represented by this position time graph. There's one motion, and this is 2 different ways to represent it. On the second one, I take the slope of this graph. Now this shows an object that is decreasing its position for 4 seconds at a constant velocity. The slope is -3 meters per second. So that is the velocity. And it's a constant velocity of -3 meters per second. And it occurs from 0 to 4 seconds. So I will draw here a velocity of -3 meters per second for 4 seconds. And that represents the velocity of that object. Number 3, you can see there's a change in the motion at 3 seconds. So we do this in 2 pieces. The first 3 seconds, I take the slope and I get -3 meters rise, which is a drop of 3 meters, in 3 seconds. And that means that every 1 second, it's a decrease of 1 meter. And now the second part of the motion here is increasing position for 2 more seconds, and I calculate the slope. And this rise here is 2 meters, the run is 2 seconds, so the slope is -2 meters over 2 seconds, which for every 1 second then, it must be a rise of 2 meters, and that's a +2 meters per second. So the velocity for the first 3 seconds is -1 meter per second for 3 seconds, and then a +2 meters per second. And I can connect these levels with a vertical line, and I also have the velocities listed on the velocity axis. And here are the results for 4, 5, and 6. This object is at rest and then moves at a constant speed of 0.5 meters per second. Number 5, the object moves 0.67 meters per second for 3 seconds and then increases its speed to 2 meters per second for the next 2 seconds. And finally, number 6, this object increases its position 0.5 meter per second for 2 seconds. Then it is at rest for 1 second, velocity of 0. And then it has a velocity of 0.5 meters per second again for the last 2 seconds.